Good morning, good evening, everyone. My name is Chaitanya Kantameti, and today I am presenting my research title Building a Real-Time Financial Trading Model Using Live Sentiment Streams. This work focuses on enhancing financial trading models by integrating real-time sentiment data from sources like Twitter and news feeds. Coming to the next slide. You can see here is the agenda. Here is the quick overview of what I have covered today. I am beginning with an introduction to the topic, followed by the problem statement and objectives. Then we will go through the literature review and proposed methodology. After that, I will present the expected result and discussion points before concluding with future directions and references. Coming to the third slide, introduction. Sentiment analysis is a branch of nature language processing that capture emotions or options from unstructured text data. In financial market, this technology helps traders understand how the crowd feels about uh, certain assets. However, most studies use historical sentiment data. My research proposes something different, leverage live social media and sentiment for the real-time decision making in trading. Coming to the fourth slide, which is a problem statement and objectives. There is a clear gap in existing systems. They rarely use live sentiment data for trading decisions. The goal of this research is to design and simulate a real-time trading model that integrates live sentiment streams. Key objectives including measuring improvements in accuracy and profitable and tagging real-time issues like latency and noise. We also ask, can live sentiment data improve trading performance? How does sentiment collaborate with price moves? And what are the main challenges in real-time implementation? Coming to the fifth slide, which is the literature review summary. Here is the brief of relevant literature. For example, Patrick and Germano explored LLMS for sentiment classification, but did not use the live data. Jing and Zhang used the fine period for stock forecasting, but again not in real time. Many studies compared model performance or integrated sentiment with stress indicators, but none of offered a comprehensive real-time trading solutions. Coming to the sixth slide, which is the literature review contributions. This research extends prior work by developing a real-time sentiment pipeline. It ingests live data from Twitter, Reddit, and news, then processes it using the fine trend where traders are executed within the sub-minute intervals. We also show that just 20% improvement in sentiment accuracy can significantly improve trading returns and short durations. Furthermore, we control for noise and latency using adaptive smoothing and natural batting. Coming to the seventh slide, which is a proposed methodology. This is a quantitative experimental study. We use Twitter and Finance API like Yahoo and Alpha Vintage. Tools include FineBet for sentiment classification, Python stimulation, and Backtracker for backtesting. Performance is evaluated using the financial metrics such as return, short operations, and statistical test. We also access the system ability to adapt in real times. Coming to the eighth slide, which is methodology flowchart. Is a process flow. First, we collect the real-time data, text data. Next, sentiment is extracted using the fine ret. Based on that, we generate trading signals, execute traders, and finally execute performance metrics continuously. Coming to the ninth slide, which is expected results and decision discussion. We expected our model to outperform traditionally passively strategies by experimentally 20% in return of trading accuracy, particularly affecting violent market where sentiment shift rapidly. It also enables early detective detection of negative market sentiment, allowing for proactive risk mitigation. Overall, it supports smarter and more adaptive algorithm trading. Coming to the 10th slide, which is conclusion and future work. To conclude, live statement integration can materially enhance real-time trading strategies. In the future, I am plan to incorporate info, info enforcement learning to dynamically optimize strategies. Additionally, this approach can be extended to incorporate cryptocurrency market, which are even more sentiment driven. I also aim to develop expansible external AI components to improve transparency and expand to multiple source integration. Coming to the 11th side, which is last one reference. Here are the sources that supports this research, including keywords by Carrot, Jung, Sobrio, and others. These references help shapes and design and direction of the study. Thank you.